hope you're enjoying pre-calculus. I laugh because I know not everybody is after, exams and stuff. All right, here we are. So 11.1 be an easy section. I think it's just solving two equations at the same time. Remember that kind of thing? There's actually a review from algebra. How do you solve two equations at the same time? They have x plus y equals 8 and x minus y equals 4. Solve for x and y. Remember this kind of thing? Sorta, kinda? Not at all? From algebra 1, algebra 2? So x plus y is 8. X minus y is 4. What do you do? There's a few methods.
Get rid of one variable.
Yeah, basically they all come down to getting rid of one letter, huh? Yeah, you got to get rid of x because we can't really do two of them at the same time. We got to get it down to just one letter. You can't have x and y. You somehow got to get rid of one of them. Now there's various ways to get rid of them. One of them is the elimination method, or the atom up. It's called the addition, or it's also known as the elimination. Another method is the substitution. And I don't, like always, I don't care which. You can type into your calculator. You can solve these in your graphing calculator. Maybe I'll show that too. Anyway, I'll just do the atom up method right now. First off, this is called the addition. It's also, it's called the addition method because you're adding them. It's also called the elimination method. Elimination, aka also known as elimination method, because when you add them, look what's going to happen to the y's. Positive y and negative y, 0, gone, bye-bye y. Yeah, which is what we want to happen, right? So I'm just adding vertically, like x and x, positive y, negative y, 8 and 4, just straight up and down, So what's 1x and 1x? 2x. What's positive 1y and negative 1y? 0, gone, as we said. And what's 8 and 4? 12. Remember that from your algebra days? And so how do you finish solve? So y dropped out, much nicer. How do you solve for x? Just divide by the 2. X is 6. Okay, so we got our hands on x. We also need y, though. Even though it dropped out, it really still has an answer. So how am I gonna go back and get the x? What am I gonna do? Yeah, plug in. Just plug in any old place, right? So take this over here, change the color here. Plug in x is 6 on the screen. Good. Anywhere. You can plug in the top equation, the bottom one. Doesn't matter at all. It'll give you the same answer wherever you go. So I'll just grab this first one here, which is x plus y is 8. Put in the 6. 6 plus y is 8. Subtract 6. Y is 2. We're done. 6 comma 2, x comma y. We got it. Remember all that kind of stuff? How could you check it to make sure it's really right? Just go back to the original, huh? 6 plus 2 is 8. 6 minus 2 is y. Is 4, I mean. Yeah. True. Yeah. So that's the answer. Now, there's other methods. There's substitution, like where you get one letter alone and plug it into the other equation. I'm not going to show that, but if you like that, that's fine too. That'll work great. You know what I want to show you, actually, is graphing calculator. But, yeah, maybe can I borrow somebody's graphing calculator? I don't have a lot of time for this, but it might come in handy. So let me show you this. Yeah, I wonder if I'm going to use up too much time. But it'll be so convenient, too. So maybe it's worth the time. Thank you, Terrence. So let me just go. I'm going to break this thing. Need to be a little more gentle with the technology. All right, so let me go up here, and I'll show y'all how to do. Let me write. How about I write out the steps first off? You basically put into matrix form. What? What do you put into matrix form? You put in 1, 1, 8, 1, negative 1, 4. See what I'm doing? I'm just grabbing the coefficients. 1, 1, 1, negative 1, 8, 4. Just put that in as matrix A or whichever one you want. And then you're going to go back. Well, there's more steps I got to write out. That's the general plan. Here's the actual steps on the graphing. Now, I don't know if you have a Casio. Most people have TI. So I'll show the steps for TI. But if you have a Casio, I can help you with that as well. I can send you YouTube or help you after class. I just don't, off the top of my head, remember the steps for Casio. I know most of you have TI. Okay, so here's the steps. Step number 1, remember as I do it, and then I'll show you on the screen. What is step number 1? You got to hit second matrix. Yeah, there's a matrix on the left. If you have a TI, on the left side, you see the fourth key down? See the x to the negative 1 power? Right above it is matrix. Everybody see that? So you had to hit second, and then the x to the minus 1 key, which is really matrix. You know, when you do the second, you know, you get the blue above it. So you go into matrix mode. So you hit that second matrix. I'll show it on the big screen in a minute. Go into there, and then you go across to edit, and hit enter. And then now you're in edit mode, and then you enter. You just say it's you got to know the size of a matrix. You guys know how matrix sizes go? What I mean is it goes down first. It's 2 down, 3 across. Whenever they enter matrix sizes, it's the opposite of graphing. You know how graphing we go over first, then up? Matrices, for whatever reason, they just decide to go down first and then across whenever they say the size. This is a 2 by 3 matrix. That's the size, not a 3 by 2. We just go down first and across. So anyway, you got to enter that. You got to say 2 by 3, enter. And then you got to enter the actual matrix, the 1, 1, 8, 1, negative 1, 4. So you put it in the memory banks of your TI calculator. And then you just hit second quit. Well, it's above. The quit is above the mode. Look at the mode key in the top row. Hit second mode, which is really quit. No, it's just quit. Once you've entered that matrix, it saves it automatically. It's got it in its memory banks. Now it's got that matrix. Then you go back into matrix mode, second x to the minus 1, which is, matrix again. Go back into the matrix mode, and then do something. Go across to, let me see, I forget, where am I at? Second matrix. Go across to the math, yeah. Go over to the math options, and go down to, they get really, really upset when you do the wrong one there. If you ever get syntax error on your calculator, it's usually that. Look back and see if you accidentally put a subtraction somewhere instead of a negative sign. All right. Anyway, so see how I've got it there? It's all entered now. 1, 1, 8, 1, negative 1, 4. It's got it. Every time you hit enter, it saves it. So I could just turn off the calculator right now. It's got it. It's got it in matrix A. It's saved. I'll just hit second quit. See up here the quit, which is above the mode key? Everybody tracking with me? Second quit. I just quit that. It's got it. It's got matrix A. Now I'm gonna go back into the matrix mode, second matrix, back into matrix mode. Go over to math. I want to see the math menu. See how I just moved to the right? And then go down, down, down. I'm in the math menu now. Go down, down, down to RREF. That stands for reduced row echelon form. Anyway, I'm not going into all that stuff. Math Excel does. I don't want to talk about it. You can take another class on matrices. You want to come by and see me, I'll be glad to explain. But anyway, reduced row echelon form. That's what it is. Did I say something different a second? It's reduced row echelon form. Anyway, that's it, RREF. Hit enter. It says, okay, what do you want me to do the RREF on? It's ready to do it. And I got to tell it matrix A. So leaving the cursor right there where it's at, I go back into the matrix mode, second matrix, and say, and now names A. In other words, name the matrix you want. I don't want to go over to math or edit. I want to stay right on names and say matrix A. Enter. There it is, matrix A. I want to do the reduced row echelon form for matrix A. You don't even need the closing parentheses. Just hit enter. Boom. Remember the answer? What was the answers we said? 6, 2. The answers appear in the right-hand column. Don't worry about that 1001. I could explain to you what that is, but our answer is right over here, 6, 2. It'll solve them automatically for you. Is that good? Questions? If you get decimal answers, do you know how to convert decimals to fractions on your calculator? Because sometimes Math Excel wants fractions. I don't care in a test. But what if I got some weird decimal answers and Math Excel wanted fractions? You guys know how to do that? On the TI, it's very easy. So you over here, the math key. It's on the left side of this math key here. Just hit math, and see that change to fraction? That means whatever, even a whole matrix. Change to fraction. There's the change to decimal option. Just hit, change it. Says, do you want me to change your answer to a fraction? You said, yes, please. Well, it's already fraction, so it didn't do anything. But that's how you, if the whole thing was decimals, boom, the whole thing will become fractions. It'll change the entire matrix. Or anything else that you ever want to change. So there we go. Questions on that? So 2 by 2, simple problem. It's not that impressive. Terrible, ugly, awful 3 by 3. Nice. You just hit the same old buttons, and with just as much ease, it solves it, and it would take us half an hour, and we'd probably make 3 careless mistakes in a 3 by 3. So that's where it becomes really useful on that. Thank you, Terrence. All right, let's go back to the main screen. Everybody got those steps copied down on that? Is that okay? Go to a new screen. All right, we'll grab it on YouTube later if you missed it. All right, so... Okay. All right, so how do we solve this one? So 2x plus y is 6. 10x plus 5y is 11. I want to solve it by hand. All right. What if I just add them right now? What if I just come in here and I go, I'm just going to add, don't write this down, this is wrong. If I just add them right now, I'm going to get 12x, 6y, and 17. Right, I just added straight. That did not work. Now, what do I mean that did not work? What didn't work? Yeah, nobody eliminated. Remember, somebody's supposed to drop out. We don't want 2 letters. We want to get down to just 1 letter. We can't have x and y. That'll mess us up. So that didn't work so well like it did last time when somebody dropped out. So what do we need to do? We need to do something first. Remember from algebra? What do you need to do? Yeah, you got to multiply by something. You got to make them opposites. Either x or y, doesn't matter at all. Just pick your favorite and make them opposites. Like I got to make the 2 x's for, let me just do the x's. I got to make the 2 x's be the same number, but 1 positive, 1 negative, so technically opposites, right? I got to make the 2 x's, or you could do the y's. It matters not. Just make somebody opposites, so that when you add them, you get a 0, and that letter vanishes, drops out, eliminates, right? Remember that game plan? So what could I do to this 2x to make it the opposite of the x below it, the 10x below it? Negative 5, right? So I'm going to take that top equation, and I'm going to multiply through by negative 5. I'm not even going to touch the bottom equation. But that negative 5 has to go all the way, right? Whenever you mess with an equation, you got to do both sides, right? So what do we get? Negative 10x minus 5y, negative 30. The bottom equation, I'm just going to bring down the bottom with no changes. Now we add them up. Sure enough, the x's cancel, just like we planned. But so do the y's. That's weird. And what's this? Negative, not 20, 19? I can't erase. Negative 19. So, what does that mean? That's weird. What is that? That is no solution. Yeah, when you get 0 plus 0 equals a number where that number is not 0, that always means no solution. If you get 0, 0, 0, that would mean infinite, which I think there's a couple that do that. That would mean infinite solutions if you get that. So 0, 0, 0 is infinite, because that is true. 0 plus 0 does equal 0. That's got some truth. But 0, 0 number, that's no solution. Is that good? Does that make sense on that? I'm not sure what your graphing calculator... Anybody put it into the graphing calculator? What does the graphing calculator say on a no solution one? Somebody want to let me know? We got that? Type that in. Let me know when you get to it. With questions on this one? So this one we would choose the no solution box. Good? All right. Let's move on. Whoops, that didn't move on. I'm going to show you how to do this one by hand and then by calculator. How about we do both? In fact, why don't we do by calculator first? 1, 2, minus 1, minus... See how I'm picking off those numbers for the calculator matrix? Right, I'm just grabbing 1, and then the 2, right, the 1, the 2, the negative 1, the negative 1. That's what I just did across the top row. I just grabbed the coefficients, the numbers, across the top row. Next row, what is it, 4? That's a 4. Go back here. So 4, negative 8, 1, negative 7. The bottom row is minus 4, 4, minus 5, 1. Put that in your calculator and do the RREF. Could I use your calculator? Crank it up real quick. Thank you. All right, so So I'm going to crank it out real quick. I don't know if you remember the steps or care to remember. Everybody got that written down? I'm just going to flash over the steps. That button. All right. So go to matrix mode, go over to edit. Oh, I'm not on the, what's this thing? There we go. No, this thing's in the way. There we go. Go over to edit, go to A. So that, now this one is, if you go back to the main screen here, this one is 3 by 4 matrix, isn't it? Remember, down and across size is down and then across. So this one's a 3 by 4 matrix, right? 3 by 4. So when you go back to the graphing calculator page, you've got to enter a 3 by 4 matrix. So it's all the same. I'm not going to write the steps out again. It's all the same steps I did a minute ago. Just a 3 by 4 matrix. It sets it up for you. 1, 2, 1, 2, -1, -1, 4, -8. Did I do, what just happened? I did something bad. It's like I wasn't looking close enough. Edit, 3 by 4, 1, 2, -1 something. -1, good, okay. And then what's the next one? And then it's supposed to be 4, -8, 1, -7, and then -4, 4, -5, 1. All right, so I just entered all the things for the matrix. Second, quit. Go back into matrix mode. Go over to math. Go down to RREF, reduce row echelon form. Say, okay, there it is. What matrix you want? I want A. Boom, give it to me. There's the answers. 1, 0.5, and 1. Now that we know 0.5 is a half. I mean, so that's simple. But let me show you in case it was an ugly fraction. You just hit math, enter, enter. Changes to fractions. -1, a half, 1. So there's the answer, all the answers to that question. So it's x is, what was it? 1, no, -1. Y is a half. Z is 1. There's our answers from the graphing calculator. What happened on that last one? With the, what was the answers on the no solution? What's the calculator say on no solution one?
0 and 1. It still gives you answers, but when you plug it into the equations, it doesn't work.
Let me see. What did it actually say? No. That would have been answers.
Yeah, but when you plug them in, they don't work. So
you must have entered something wrong.
I entered it both ways. I entered them after we multiply by -5.
This one was what was the original question? 2x plus y equals 6 and 10 plus 5y. Did you guys get that answer? Let's go. Let me go back. So let me go back. Where was that one?
Oh, yeah. And then you go back to the matrix.
And we multiply by so 10, 5, 11. Yeah, that's right. Okay. Matrix. Reduce row echelon form. Matrix. Oh. Yeah. Okay, yeah. Let me go back. Yeah, I see. You're right. That is what it says. Let me explain what that means. Okay, so jumping back real quick. Sorry, I'm kind of being kind of confusing. I should have stopped right there. Going back to the last one we did, to problem number, whatever it was, 3. Going back real quick. When we said it was no solution, which it is. Indeed, it is no solution. I wanted to show you what the graphing calculator says if you type it in. The answer on the graphing calculator is the following: 1.500001. That's what the answer on the graphing calculator is. That means no solution. How do we know? Because It's, you know what, the answer, remember how in the beginning, yeah, look right here. See how we took this and went to that from the beginning? We just peeled off the 2, 10, 1, 5, 6, 11, right? And turned it into a matrix. Well, basically if you put these, so notice there's x's down the first column, then y's, then just numbers, right? So put that back into your answer. These are x's, these are y's, these are equal signs. That's what it means. That's what that answer matrix means. That makes sense. I'm just putting back in the x's, y's, and numbers. Okay, so what? Well, what is this saying? This is saying no x's plus no y's is 1. That means, that's craziness. That means no solution. Do you see that? So when you get, see, that can't be. What x and y could ever make that true? What could you ever plug in for x and y times 0 that adds up to be 1? That's just like this, isn't it? It's craziness. Yeah, so that is what it says. Thank you for clarifying. That means no solution when you see that on your graphing calculator. Makes sense? If you have all zeros and numbers, it's the same issue as I said right here. If you have all zeros and a number, that's no solution. Same thing on the graphing calculator. If you have any row that's all zeros and a number, that's no solution. That can't be. That's impossible. That's what it says. All right, does that make sense? You guys okay with that no solution, the way the graphing calculator shows it? And then back over here, did you guys get this one okay? So I did it by graphing calculator. Let me show it by hand now, which is much more painful, and will take most of our time. All right, let me do one. I'll do one by hand. All right, so by hand, how will this work? On the test, because you're probably wondering, well, what do we have to do on the test, Mr. Herring? On the test, I can't exactly remember. I'm pretty sure you won't have to do a 3 by 3 by hand. Yeah, let me guarantee that. 3 by 3s, you can use your calculator. You might have to do a 2 by 2 by hand. You should be able to, yeah. So I'm going to say it's fair game. I could give you a 2 by 2 on part 1 where you have no graphing calculator. So you need to be able to do a 2 by 2 by hand. 3 by 3s, fine with me, just use your calculator. I won't put a 3 by 3 on part 1. Make sense? I'll guarantee you don't have to do a 3 by 3 by hand. But you do need to do a 2. In fact, since, in the interest of time, I'm not going to do this 3 by 3 by hand. Come see me. Be glad to show you by hand, but I won't put it on the test. No 3 by 3s by hand. Just 2 by 2s by hand. Make sense? So I'm not going to do it because there's other things to spend. They're going to give us some word problems that turn out to be 2 equations with 2 letters. That's basically it. You know, we've been solving 2 equations, 2 letters. They're going to give us word problems that do that. So okay. So how do we do this one? Perimeter of a rectangle. So if you have a rectangle which has a width, a length, and a length, what's the perimeter formula?
2 times the width plus.
2 widths and 2 lengths, right? Perimeter is just width plus length plus width plus length. 2 widths and 2 lengths all added up. Perimeter just means around the edge, right? It says the length is twice the width. That means L equals 2W, doesn't it? Oh, and the perimeter they said is 90, so I'll just replace perimeter with 90. So we got 2 equations with 2 letters. Notice 90 equals 2W plus 2L, and L equals 2W. See that? 2 equations, 2 letters. You can type them in your graphing calculator, but you'd have to rearrange them. Or you can just solve them by hand. How about I just solve by hand? So how would I solve these 2 equations? You have to have the same number of equations as you do letters. So with 2 letters, you need 2 equations. We've got that. Do you know this one would be real nice for substitution? Is that what you guys are thinking? This would be real nice to plug one into the other. Let's go ahead and do that method. You know what I mean by that? See how the bottom one says length equals 2 width? That means wherever you see L, you're allowed to replace it with 2W because L is 2W. Huh. So I can come up here and go, oh, I'm going to stick 2W in right there. So plug L equals 2W into the other equation. That's how the substitution method always works. You plug one equation into the other. So then what is the top one becomes 90 equals 2W plus 2L, but instead of L, what do I put in L's spot? 2W, because L is 2W. That making sense what happened there? Mm-hmm. I just wrote out the top equation. 90 is 2W plus 2L, but instead of L, L is 2W. what does that do? That gives you an equation with only one letter. Remember, that's the name of the game, huh? We can't have two letters at the same time. See how this thing only has W now? So now I can solve for it. So it's just another method you might remember from your algebra days. So let's solve that then. What do we got here? 90 is 2W plus, what's that, 4W? 90 is 6W divided by 6. What's that, 15? W is 15. We've got the width. So then you just plug that in. L is 2W. You can plug it in. It'd be easier to plug it in the bottom one. You can plug it in either one. It'll work either way. So L is 30, huh? So the width is 15. The length is 30. And we got it. Is that good? Questions on that? No questions? Can I flash you another one? Okay. One year there was a total of 38 commercial and non-commercial launches. So I'm going to go commercial plus non-commercial, total 38. Add up to equal. So that makes sense how I interpreted that first statement? 38 total, commercial plus non-commercial. I think it's easier to use letters that are meaningful for you than X and Y. That way you'll remember what stuff is. But you can use X and Y if you want to. In addition, the number of non-commercial was 5 more. So non-commercial was is past tense of is, so it's equals, right? Non-commercial was, non-commercial is in the present tense. 5 more, 5 added to, right? 5 more than twice the number of commercial. There we go. 2 letters, 2 equations. That good? Could we type it into our graphing calculator? Let me show you that. Or you could do plug. Yeah, this would be another plug-in to be easy, huh? Mm-hmm. See how that second equation's just begging for a substitution, right? He's saying, look, n equals 5 plus 2c. Therefore, plug that in for n in the other equation. So the other equation will become c plus n is 38. But instead of n, I'll put in 5 plus 2c because n is 5 plus 2c. Everybody see that, how I did substitution? Substitution's real nice when one letter's already alone in one of the equations, huh? That's when it's real nice to just plug it in, huh? So we get c plus 5 plus 2c. I guess I didn't really do anything there. How about I combine those like terms, c and 2c? 3c. Subtract the 5. 3c is 33. Divided by 3. c is 11. 11 commercial. And then plug in to get the other one. So c plus n is 38. Plug in, c is 11. 11 plus n is 38. Is that on the screen? Yeah. Subtract 11. Non-commercial is 27. 27 non-commercial, 11 commercial. We good there? Questions on that one? Let's see what else they got for us. Harkening back to your algebra days. Were those glorious days for you? Let's see what you remember about word problems and solving 2 equations. All right, store sales. So whenever you do a money problem, usually you have one equation that's, well, let me put it this way. One equation that's no money, and the other one that's money all the way. Okay, so the no money equation, let's see. What are we talking about? Cashews, peanuts, 70 pounds of peanuts, and sell the mixture for $4 per pound. Oh, it's a mixture problem, really, which is kind of money too, but it's especially, really, mainly, it's a mixture problem. Okay, mixture, I do the beakers, that's what everybody does pretty much. I'm just doing traditional method here. Just the beaker thing, like 3 buckets, the chemistry lab kind of thing, 3 beakers, right? Okay, store sells cashews. So I'm going to put the money in here, the cashews. So let's say C for how many cashews. So when you do a mixture, remember that from your algebra days? You put in the top the amount, and you put in the bottom the percentage or the dollars. In this case, it's dollars on that. So along the bottom, so across the top goes amount, across the bottom goes dollars or percentage. So C is the amount of cashews, P is the amount of peanuts, I don't know, at $3 a pound. Sometimes they give you percentages, acid is 70%, or something, a chemical 70% acid or whatever, you know, dollars, percentage, whatever. Mix 70 pounds, that's the total over here, that's what they equal, that's the total amount. And it's going to sell for $4 a pound, the mix. They're going to mix the more expensive stuff, the cashews and the cheaper peanuts, and get a mix at $4 a pound. Is that good? That makes sense there? So we set up the mixture. This is the final product, right? They're mixing more expensive and cheaper stuff to get a $4 mix. All right, so two letters, C and P. How do I get my equations? The first one's right across the top. So first equation is just the tops. C plus P equals 70. That's just total amount of nuts, right? However many cashews, however many peanuts, 70 pounds total. That makes sense, right? The second equation comes from multiplying top and bottom. Multiply the top and the bottom. So 6 times C, 3 times P, 4 times 70, which is 280. Everybody see what I did there? I did. I went multiply, 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 top, bottom. That's how I get my second equation. That equation has to do with money, doesn't it? That's the money equation. Meaning, if the cashews, C is how many pounds of cashews times $6 a pound. That's the total monetary worth of all the cashews, isn't it? Does that make sense? If I said, hey, we have 10 pounds of cashews, okay, well then times $6 a pound would be $60 worth of cashews, right? Whatever C is, this is the money the cashews are worth, and 3 times P is the money the peanuts are worth, and then 280 is the total money. How do we know? Because we're making 70 pounds of a $4 per pound mixture. $280 worth of the mixture, right? So that money plus money is money. It's in the second one, huh? Questions? Samantha?
The amount of peanuts, not the total.
Oh, is it?
Pounds of peanuts.
Oh, goodness gracious. I'm all messed up. I should read more carefully. You're right. Thank you, Samantha. That's all wrong. Let me go back. Thank you. And it's not a major fix, but we need to fix it for sure. Let me see. This was cashews. Peanuts is straight 70. Thank you. They're telling me the peanuts right there is straight 70. So then this is C plus 70. Does that make sense there? So let me fix my two equations. Everybody see what Samantha noticed that I did not? It's the peanuts that's 70, not the total mix. They usually do the total mix, so I was just assuming that they were doing that and not reading closely. So that top equation is meaningless. I mean, it's true, but it's not going to do anything for me. Does everybody see that top equation? C plus 70 is C plus 70. This just in, shocking result. Obviously, that equation can be skipped. It's already there. And the second equation, 6 times C plus 3 times 70 is 4 times C plus 70. The whole answer will come out of the second equation. See the second equation? Has only one letter. So this is actually easier. So we just solve that second equation, right? 210. So I'm doing the same thing, right? I did multiply, multiply, multiply for the second equation. Multiply here, 4C plus 280. Then just solve for C. Can I just go dot, 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 just solve for C. We already know how many peanuts. All that's left to determine is how many cashews, right? And you'll find it when you solve for C there. I mean, I could do it quick if you want. 2C is going to be 70 divided by 2. C is 35. 35 pounds of cashews. I skipped a couple steps there, if that's okay. We good? Thanks for the clarification, Samantha. Everybody see that? They were giving me how many peanuts. And this, everybody see why this is C plus 70? Because C plus 70 is C plus 70 up there, right? Total pounds. If C is how many pounds of cashews, 70 is how many pounds of peanuts, then C plus 70 is how many pounds of the mix, right? All right. All right, tailwind, da da da. What formula do you use for travel? What's the travel? Whenever you got trains and planes and cars and motorcycles, boats, distance is rate times time. Dirt, I had a student more than 20 years ago, because I'm old now. Say the dirt equation, Mr. Aaron, the dirt And I'm like, sure, that works. We'll go with that. So it looks like the word dirt. That helps you remember it. The dirt equation, d equals r times t, distance equals rate times time. Tailwind, small aircraft can fly 1,000 miles in 4 hours. Against the same wind, the plane can fly the same distance in 5 hours. Okay. So normally I put boxes underneath them. That normally kind of helps. So we've got with the wind and then against the wind. So those are the, we don't have like two different planes or something. We just have the plane with the wind and the plane against the wind here. Now, what does it mean when you're with the wind? What if I said, hey, I've got this little plane that can go, I don't know, 15, well, they go faster than that, huh? Let's say the plane can go 100 miles an hour on its own, and the wind, so the plane can go 100. The wind is blowing at 20. So how fast am I going to go with the wind? 120. You just take the 100 and you add. That's when you're with it. And when you're against the wind, what's going to happen when you turn around, go against the wind? It's just going to subtract the 80, huh? We all know that and sense it, and that's true. Right? So when you're with the wind, just adds to your speed. And when you're against it, it subtracts. So what that means, notice, is it's wind plus the plane. Well, the bottom one is minus. When you're against, it's minus. And when you're with, it's wind plus the plane, huh? Well, I got that reversed. It's plane first, huh? I'm trying to go too fast here. So it's plane plus the wind and plane minus the wind, isn't it? Plane speed plus the wind when you're with it. So that's what we do here. And those are rates. Those are the middle boxes. That's not distance or time. That's speed. That's rate. So plane plus the wind when you're with it, and plane minus the wind when you're against it, huh? Okay. So what's it saying? It can do the trip in 4 hours. That's the time with the wind. It's 5 hours is the time against, right? Against the same wind, 5 hours is the time. Good to there? Now, how do you get D? It equals the R box times the T box. So says the relationship. D equals R times T. So that means this D box here is going to have 4 times P plus W. This one's going to have 5 times P minus W, right? Doesn't matter what order you write them in. Is that good? Because distance is rate times time. Okay, so what now? What do we do now? It says, what else does it say? Well, you tell me. Is the distance is 1,000 miles, huh? The distance is 1,000 miles. So, 4 P plus W is 1,000. And 5 P minus W is also 1,000. They're both equal to 1,000. It says right here, 1,000 miles. And the return trip's the same distance. So both those equal 1,000. So that's 2 equations, 2 letters. Can I go dot, dot, dot now? Then you just solve those 2 equations. You got to distribute the 4 and the 5 and, do your thing. Either, I'd probably do the addition method, or you type it in your graphing calculator. Solve it that way. Does that make sense? What I did there, right? So everybody see that? So the 2 equations would be, let me bring it up here maybe. So I never want to stop. I want to keep this. So I look at your faces and I get this, I'm not sure, Mr. Heron. Look, so then I think, I better solve it. 5P, and I remember how I used to always hate it when the math teachers would say, right, you get it from there, right? I'd always think, no, I don't. I don't get it from there. Why don't you just finish it? All right, so there it is, right? I just distributed the 4 and the 5. Boom, 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 boom. And then, how am I going to solve these 2 equations? Well, you can type in your graphing calculator, like I said, or you can do I'd probably do the addition method. I could make both, you shouldn't erase them. I could make both these guys into 20, couldn't I? Do you know what I mean? I could take that top equation and multiply it by 5, and the bottom equation and multiply it by 4. Boom, 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 boom. See what's going to happen? I'm going to erase some stuff now because I'm running out of room here. Erase this over here. And so then I'm going to get what? 20p plus 20w is 5 times 1,000, 5,000. And 20p minus 20w is 4,000. See what I did? Now when I add them up, the w's go bye-bye. Remember, that's the name of the game. Make opposites, huh? So I made it plus 20w and minus 20w. I had to multiply both equations to make that happen, though. Remember these from your algebra days? So now, what is 20p and 20p? 40p. What is 5,000 and 4,000? 9,000. Now divide by 40, and we've got the speed of the plane, whatever that may be. Got no idea. 225? The plane speed is 225. We could plug back in and get the wind speed on that.
Couldn't you have just divided by 4 hours? That would have given you...
Oh, that would have been nicer. Oh, yeah, good idea, Terrence. That would have been a lot easier, huh? Just divide by 4 and divide by 5, huh? That would have been better. And then just add them and bye by W. Oh, yeah. I didn't need to do all this work. Yeah. Everybody see Terrence's idea? Just come back to this equation, and I don't know where to do it. I just don't have any more room. But, yeah, you could have just divided by 4, and this one divided by 5, divided by 5. And then this would have been, here, I'll change my color here. This would have been P plus W is, what's that, 250? And this would have been P minus W is 200. See what happened there? If you divide both these by 4, both these by 5, right? And then you can just add up these equations. The W's drop out. 2P is 450 divided by 2, 225. A little quicker. P is 225. A little better way. All right, enough. Now, pressure in your minds, right? Oh, well, yeah, let me tell you what part 1, part 2 are. Maybe you don't know that's true. Probably nobody does. Part 1 is all the, what I'm going to give you on the exam Thursday. Part 1, this is part 2, but if you look back at part 1, it's all the hyperbola, parabola, ellipse stuff. It's chapter 10. So part 1 is the chapter 10. So let me write that somewhere. Part 1 is 10.2, 10.3, 10.4. It's all the graphing. It's all the graphing of, parabolas, which is 10.2, ellipses, the egg shapes, which is 10.3, and the hyperbolas, which is 10.4. So that's what part 1 is about. That's fresher in your minds. We did that this last week. So I think you'll have less need to review that. I mean, you should definitely review. But I think I would do you more good if I spent the next 50 minutes reviewing part 2. That's been longer. That's been chapter 5. That's 5.5 through 5.8 is part 2. Does that make sense? So part 1, you will not have your graphing obviously, I mean, what am I going to do? You're not going to have your graphing calculator on the graphing stuff, right? I want to make sure you can graph those by hand. So that's how part 1 will be. It'll be all those. Look at it. Take a look at it. It's parabolas. I'll give you two parabolas, 2 hyperbolas, 2 ellipses. Well, I think there's like 8 questions. So then maybe 3 parabolas, 3 ellipses, and 2 hyperbolas, probably. 1 word problem, like a satellite dish or a bridge or something. And probably it's 1 forward, 1 backward of each type. Like, no, you know what I mean by forward? I'll give you an equation for a hyperbola and say, draw it. And then I'll give you a picture and say, give me the equation. Right? I'll have 1 forward, but that's pretty much what's going to be. There'll be 1 forward, 1 backward for parabola, 1 forward, 1 backward for ellipse, 1 forward, 1 backward for hyperbola. Then there'll be a parabola word problem or an ellipse word problem, and then some other thing like that. There's going to be a completing the square, as I promised, for sure. Right? Make sure you can complete the square. Magic number, be over 2 squared, add it to both sides. That whole thing, that's for sure on there. Make sure you can do all that. All right. You know the secret to doing well in math, right? Do the problems 10,000 times. I mean, really. I mean, it's true, right? A lot of people say to me, I can't do math. I can't do math. Over my 24 years of teaching, I would say usually, I don't want to set like for sure, but most of my experience with those who can't do math, it's more true to say they won't do math. They will not give it the time it demands. They could do it, but they're not willing to give it the hours that I gave it, for example. They're just not willing to do that. When I see what they're doing in their homework, I think, yeah, I couldn't do math in just putting in that amount of time either. No, I would hate math too, right? Because I would fail it if I only put in that many hours. That's the truth of the matter. So I just say that to help you. Just speak the truth to yourself and decide if you really want a math science degree. If you want a math science degree, you have to give your life to these kinds of classes. Chemistry, physics, calculus, it is not going to come to the casual. It just will not happen. You have to do these problems. Like I told you, my wife would do them 2 times. She's getting ready for Thursday's exam. My wife would not just, she would laugh at the practice exam. She would do all the homework again, all these sections, 5.5, 5.6, 5.7, 5.8, 10.2, 10.3, 10.4. She would redo every problem again. I didn't do that, but I would look them over. I would have done them once the first time, and then I just glance at it, yeah, I could do that. I go, oh, no, I'm not sure about that one. Then I would redo that one. I would just do that kind of thing. So anyway, there it is. There's what it takes. There's the reality. So make your choices on that. So, all right, so let's go through this thing. How do we do the log when there's a couple of numbers like that? Log base 2/3 of 19. What do we do? Yeah, remember making it into 2 logs. The high goes high, the low goes low. Just hit the buttons on your calculator and you're done. Remember that? Hey, can you hit that real quick? Because I know a lot of people have calculator trouble. I'd be glad to help with that. Let's make sure you're getting this one okay. Log 19 over log 2/3. You like that 2/3 to be in parentheses, huh? I think y'all know that. Anybody got it? What is it? 7.6. Anybody else getting 7.6? So negative?
I don't know. I
No?
don't have a negative, but.
Can you use your calculator again real quick?
Log 19.
Thanks. Yep, just log 19. Log 19 divided by log 2/3 is negative 7.26. 26, blah, 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 blah. Okay, is getting that okay?
Do you say, 2 decimals?
Yeah, I don't care, but yeah, what does it say? 2 places. So yeah, anyway, so I just want to make sure you grab me after class. If you have any trouble, take 10 seconds. I was always asking my teachers questions. I can't believe how nobody asked me questions. They're either way smarter than I was or less interested in doing well than I was. So grab me. I'd be glad to help. Grab the tutor. Glad to help. After class, I usually answer 1 question after class, office hours. I'd be glad to help. All right, bacterial culture, initial population, 10,000. Declines to 4,000 in 4 hours. What's it going to be at the end of 6? What formula do we use on these exponential growth and decay problems? PERT. Our friend the PERT. A equals, PERT's right up here at the top. Yeah, there it is. Right, we always use the PERT on all the exponential growth and decay problems. Always use the PERT. All right, so initial population 10,000. What do we do with that? Where does that go? That's the P. That's the P. And it declines to 4,000. Where's the 4,000 go? The A, huh? Oops, that's a big comma. Declines to 4,000 in 4 hours. Time 4 hours. Everybody see what I did there? When time is 4 hours, the amount has gone down to 4,000. It started at 10. Remember what you do in phase 1? Phase 1, solve, well, let me write it somewhere else where it's not in the way. Amount, yeah. So phase 1 is find R. Remember that? We always find R in phase 1. So let's solve for R. Divide by, and then we restart. Remember how these are always 2-phase problems? Phase 1, you do the work to find R, then you restart with the PERT formula and finish in phase 2. Divide both sides by 10,000, that's 0.4 is e to the R times 4. Good so far. Bring it up here. 0.4 is e to the R times 4. What do I do to solve for R now? ln, our friend, whenever the letters climbed into power. You know it quite well. ln to both. That's one thing you'll never forget from this class, right? When the letters in power, I know what logs are for. I hope that came across. We've talked about it a lot. ln of e is just 1. Remember that? How do we solve for R? Divide by 4. Whoops, I crossed out the R. That's not right. There we go. So R is ln of 0.4 over 4. That's phase 1. I'm done with phase 1. Now comes phase 2. What's phase 2? You start again with the PERT. But now you're going to grab all of this and put it in for R, because that's what R is, and then you'll finish the problem. I'm out of room. I think I'm going to erase up here and come up here and finish the problem. Y'all getting that down okay? Erase all this stuff. So come up here. All right, so coming on up here. So A is PERT. And I know this is phase 2 now. We got our hands on R. R is phase 1. Phase 2, do the PERT. What was P is 10,000. What's R? Now I know R. It's ln 0.4. ln 0.4 over what? Over 4 T. Everybody good to there so far? I just plugged in R, plugged in the P. That's a big 0.4. ln 0.4.
So do you not put in for the A and the T, or we do still?
So now, yeah, what's their last question? What will be at the end of 6 hours? So they want me to put in the T. Yeah, good. The T is supposed to be 6 hours, isn't it? That's the final question to us, right? So I put in the time as 6 hours. Everybody seeing that? That good? Now, you could just hit the buttons on your calculator if you want to. I was helping somebody in my office just today with this exact one. It was a good question. Please make sure, hit the buttons right now. Can you get the answer? Make sure it's not easy, right? These are tricky, complex calculator ones. I think it's easier. Remember how I showed you back when we were doing the homework is to slide this over, just move that 4 over like that. See what I'm doing like that? Just move that 4 over. Why? Because those are just two fractions. Do you see what I'm doing there? Like if I had 2/3 times 5, for example, which is, as you know, 10/3, right? I could just move the 3 over here. It's still 10/3, right? It doesn't change anything. If you just have one denominator, you can put it underneath either part. It's still 10/3, right? That's all I'm doing. Does everybody see that? When I slide that 4 over, I just want to get it out of the natural. Why? Because then these guys can cancel, right? E and ln, and the 0.4 can drop down to the base. It just makes it cleaner, easier to type in your calculator. See what happens? I just move the 4 over, why? Because the 4 was never, the 0.4's in the natural log, but the 4, the plain 4, was never in the natural log, was he? Remember me always beating the drum about the toaster, right? Function, sine, cosine, tangent, natural log, e, they're all functions. And you want to be clear what's plugged into the toaster and what's outside of the toaster. I've noticed students are always turning those around. So you really want to pay attention to that, right? This 0.4, he's like, I'm in the toaster. But the other 4 was over here just underneath. He's not plugged in, right? You always want to be clear on that. Who's in the toaster, who's out. So that 4 that was out, I just moved him over. He was never in there anyway. These guys canceled, and the thing in the toaster popped out. All right. So then it's easier. Hit the buttons. What do you got? 25,029.
I'm sorry, no, here you go. 29.
25,298.
No.
Oh, 25. Oh, okay. 2529.8. I don't know how far I'm supposed to round or whatever. Thank you. Good. Questions on that? If you can't get that in your calculator, grab me after 10 seconds. Be able to help you.
The population doesn't have to be a whole.
Yeah, whatever. This is all just approximate anyway. I mean, they're not going to be exactly 2529. Whatever it is. What are these things? Bacteria. There's exactly 2,529. There's not 30. It's rough. It's estimate rough.
Okay.
Yeah.
So you don't care how we.
I don't care. What did I say? Round. I didn't even say. So if I don't say, who cares? It's all good. I don't care how far you round. Number 3, population of certain country doubles every 28.8 years. Find the growth rate K. So we're using PERT again. A K is the same thing as R, isn't it? K is the same as R. So go ahead. My pen just died. I'm going to have to plug it in. So write down PERT. I'm going to give you a second to solve that while my pen charges back up. So try that. It's supposed to be a T up there, but I Here, I'll do it too with my finger. There. So solve that. So the K is the T. I'm sorry, the K is the R. They're using K. I usually called it R. Doesn't matter. That's what they want you to find. They want you to find R. So plug in. It doubles every 28.88 years. Right? So what does that mean? The amount becomes what? In 28. When time becomes 28.88, amount becomes 2p. Right? Good. So that makes sense. Plug in time is 28.88, and amount becomes 2p, huh? Now go ahead and solve that. And then you just cancel the p on both sides. Just divide by p on both sides, huh? It's gone, right? Let's divide by p. That's really what I just did there. Whoops. Having problems here. Come on. There we go. Divide by p on both sides. Cancels out. So 2 equals e to the r. 28.88. Solve for r. Right? Solve for r there. Take the natural log of both sides, right? And that's all they want. All they want you to, basically they're just asking us to do phase 1, huh? We don't have to do phase, normally we have like, once we get R, that's just phase 1, like on the last problem. And then we got to plug it back into the PERT and do something else. This one is just a phase 1 question. Just find R. Just find K, they called it. I'm going to charge this thing up real quick. Oh, I don't even care. Yeah, I didn't know what it said, decimal or fraction or what it said. I'm not
Give
picky.
an exact answer, not a decimal answer.
Okay, there we go. And so I guess I just want you to leave it. Exact answer. Yeah. So what you guys get? ln of 2 divided by 28.88? Yeah, so it should be ln of 2 over 28.88 should be your final answer on that one. Let me see. All right, so back here we are. Yeah, so in the end then, when you do the ln of both sides, ln, this power drops down, so you get ln 2 is r, 28.88 ln e. ln e is just 1, divide by 28.88. And there it is. Here's what they want. All right, let's. Okay, so number 4. How long does it take 1,700 to double? It is vested at 5% interest combined monthly. Da-da-da. Okay, is this a PERT or the other formula? It's the other one, which is right at the top of the test. P1 plus R over N to the NT. How do we know it's not PERT? It's not growth or decay. Those are always PERT. But some of the money ones are PERT. Which money ones are PERT? Continuously compounded, right? So all the growth decay ones are PERT, and then for the money ones, if it was continuous compounding, it would be PERT, right? But it's not continuous compounding, it's whatever monthly, compounded monthly. So we use this formula, right? So PERT is for growth and decay and continuous compounding. That's when we use PERT. This one is monthly, which means N is 12, huh? 12 times a month? No, 12 times a year. And that formula is given right at the top of the test, along with PERT. Don't even have to put it on your 3x5 card. All right, so how long does it take 1,700 to double? So basically, the principal is 1,700, and the amount is 3,400, right? Double 1,700 times 2 is 3,400. R, the interest rate is 5%, 0.05. The N is 12. There we go. Now, really, you could have just skipped the whole 1,700 and just made A become 2P, because that's what's going to happen on your first step here now, isn't it? You divide both sides by 1,700, and you're going to get 2 equals 1 plus 0.05 over 12 to the 12t, huh? Does that make sense? We good there? Now what are we going to do? Where's T? T has climbed into power, right? T's climbed into power, so ln on both sides. The 12t drops out of power, right? Whenever the letter's in power. Whenever the letter's in power. Yeah. So ln2 is, whoops, I forgot to put the 12t in the front. 12t ln 1 plus. Somebody have that, what is that number? What is 1.0? Well, it doesn't matter. You can just leave it this way or get it on your calculator. Doesn't matter. Almost done. Once you get that letter out of power because of the natural log, you're almost there. What do? T saying, I want to be alone. Here I am, I want to be alone. So what are we going to do? Just divide. Now just divide. Both sides by 12 ln of 1 plus 0.05 over 12. And t is alone. Make sure you can do that in your calculator. Somebody got a number there? It's ln 2 over 12 ln of 1 plus 0.05 over 12. Now, if you have a calculator that's the newer kind that like makes it look like a big fraction, then great. Just type it in like it looks, no problem. If you have the old kind that puts it all on one level like mine, then you're going to have to put parentheses, another set of parentheses, around that denominator. Why? Because we have two things. We have a 12 and an ln. Whenever you have more than one item in a numerator or a denominator or a power zone, you've got to put parentheses around it. Otherwise, it'll only divide by the 12. Somebody got it? What's my t? What is it? 13.9. Is that right? Remember the rule of 72? Is that about right? Remember the rate and the time multiplied to be about 72? 5% times 4. Yeah, that's close to 72. 5 times 13.9 is real close to 72. Looks about right. Anybody else getting that? 13.9%?
I got 13.89, so yeah.
Yeah, so it rounds off. Oh, that's not percent. That's time. Years. That's how many years it would take. Good. All right, questions on that one? We good there? Or you, we're up at number 4. So number 5. Sydney requires $13,000 in 4 years to return to college to get an MBA. How much money should she ask her parents for now? So that if she invests 11% compounding continuously, she will have enough for school. All right, is this PERT or the other one? Compounded continuously. So indeed it's PERT, right? All the growth and decay and the continuous compounding are PERT. All right, so we're going to use PERT. All right, she will require $13,000 in 4 years. She will require. So that $13,000, is that what she's got now?
No, that's the A.
That's the amount. Yeah, that's the A, isn't it? That's what she wants the amount to be later. The P is what she's going to ask her parents for. What principal should she put in the bank now? The interest rate is 11%. The time is 4 years, right? That good? Do I need to do ln? Both sides, ln? The letter's not in the power zone. No, it's just divide, huh? Just divide by that whole e to the 0.11 times 4. Right? Boom, boom. P's alone. Whatever that comes out to be. Somebody got it? Like 9,000 something, I think, isn't it? If I remember the answer right. Was it 80? 8,000 something? 83.72. So 83.72 and some change. Good. It's kind of impressive, isn't it? 8,000 will grow to be 13,000 in only 4 years. Of course, you gotta get 11%. I don't know where you're gonna get that. Anyway, that good? Questions on that one? Let's go on to number 6.
No, this is 13.
Oh,
Certain artifact, blah, 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 60% of its carbon-14, half-life is 5,600 years. Now, I gave you, for half-life, I gave you a shortcut form. There's probably a half-life problem on this next exam we take on Thursday. Remember, for half-life, I gave you a shortcut. I said you can basically skip phase 1. These will be actually easier if you write down the shortcut, because normally, we have to do phase 1 and phase 2 on all the exponential growth and decay problems. But for the half-life, I gave you a handy-dandy formula. I said, look, for half-life, you can just go 0.5, that's the half, to the t over whatever they tell you is the half-life. Right? You can just use that shortcut formula for half-life. It's the result of phase 1 is what it is. So you just go, 5,600 years is the half-life, so you just use A is 0.5 to the t over 5,600, and you just jump right to the end of the problem. You should be eager and excited to see the half-life question if you write this on your 3x5 card. So write this on the 3x5 card for half-life problems. This is what you can do, a shortcut for the half-life problem. Okay, so now all I got to do is plug in the time, right? Oh, no, I don't. No, this is still harder. Okay, so we're good to there so far, right? So there's our formula. There is my formula. Now I got to plug in whatever they're giving me. They're not giving me time. That would be nice if they gave me time. But they're not. What are they giving me? What fact are, I've already used the 5,600. 60%. So they found some artifact and it had lost some of its carbon-14. It had 60% remaining. So what does that mean I do? And that's the A. The A is 0.6, isn't it? Oh, I forgot the P, didn't I? Sorry, guys. I'm being a little too short. There's really a P there. There's really a P there. Sorry. There's a P in front of that 0.5. So the A is 0.6P, isn't it? In fact, let me just bring it over here. The A is 0.6P. Good to there? So the amount of carbon-14 is 0.6P, 60% of the original principal. Well, it's not money, but of the original amount. Is that good? So now we just divide by P on both sides. It's gone. So I've just got 0.6 is 0.5 to the T over 5,600. How am I going to solve for T? Where's T? Power zone, Ln, same old, right? Ln both sides, the T over 5,600 drops down. Ln 0.6 is T over 5,600, Ln 0.5. Good to there? That T over 5,600, that whole power dropped down to the front, didn't it? All right, how do you get T alone? Yeah, just divide and multiply. So divide by the Ln 0.5. That's gone. I'm totally out of room now. Come up here. So coming up here. So I've got Ln 0.6, Ln 0.5 is T over 5,600. Last step to solve for T. Multiply by 5,600. Boom. T's alone, there it is, whatever that is. That's how old the thing is. We good there? Questions on that one? Anybody got that number? What's that?
4,127.
4427? 4,127?
Yes.
4127, thank you. Not many years old. Questions? You have trouble with that? Grab me after class. Can I flash to a new page? Got that down?
You work that Ln 0.6 over Ln 0.5 first before before you times it by the 5,600?
That's,
Yeah,
that's like
that's what you, okay.
Yeah.
Just curious.
All right, so how do we solve that one? It's e to the 2x equals 7. Want to solve for x? What are we going to do? ln. It's like the answer to half the problems on this part anyway, huh? Because the thing's starting to have trouble, huh? Probably going to go out any second like it always does, huh? So, ln both sides, right? Y'all with me? Because why? Because x is in power. So whenever the letter's in power. So then the 2x drops down. 2x ln e, ln 7. ln e is just 1. You know that. So 2x is ln 7. Last step to solve for x. Divide by 2. We're done. Leave it that way. Or they want decimal, huh? So whatever your calculator tells you on that one. All right. Let's try number 8. Well, I'm going to go to fresh. Well, no, we can do it. Okay. I'll squeeze it in right here. So for this one, so for 5 to the x plus 6 is 7x. It's going to do this. I'm going to do the same thing on this one, huh? I'm going to do ln of both sides. Because again, x is in power, right? Both these, x is in power. Now number 8 is going to be a little harder, though, because there's more mass. So ln of both sides, bring the powers down. It dethrones the powers, same.
You don't want it? Or would you give it a 1?
Okay, so number 9. So log base 10 of 17 root x over y. Write as a sum or difference of logs. So do you see what they want me to do? They want me to take that one log and make it into several logs. So how do I do it? How do you take that one log and make it lots of logs? So the log base 10, that's always going to be log base 10. That the 10 doesn't go anywhere or do anything. It's glued to the g, right? The base is just stuck right there. All right, so then you have the 17, you have the root x, and you have the y. It's plus, and it's minus. I'll do one more thing, but so far so good. Does that make sense to there? Right? Things in the top are multiplied, so that's adding. Remember that? And anything divided is subtracted. The y is divided, so it's subtracted. Remember, dividing goes with multiplying. Adding goes with times, right? Dividing and multiplying both make things smaller. Adding and multiplying both make things bigger. So far so good? Now one other thing. What can we do with that root x? Yeah, root is a half power. Remember that? Root on anything, even on a big old honking thing, is a half power, and that half power jumps down to the front of just that log, not of everybody. And there she is. Good, I did what they said. I made it into a sum or difference in adding or subtracting of several logs. All right, now number 10 wants you to go the other way. Make it one log. So 10 runs the process backwards. Number 10 says, hey, I got 2 logs. Put them together, make it one log. So run the properties backwards. Try number 10 there. So first off, that half just distributes. Nothing magical there. No special log properties or anything. I'm just distributing. Minus, distributing the half. So far, so good. That's just normal distribution, like from algebra. There's a half in the front of the parentheses. Let it distribute to the front of each log. That's just nothing fancy there. Now, what does that half power do? Zip up to the power. Zip up to the power. Remember? Numbers in the front, go to the power. So this is log base 7 of x minus 3 to the half power minus log base 7 of x to the half power. Those halves in the front go up to the power, don't they? Remember, numbers in the front go to the power. And then, what's a half power? That's a root on both those. Finally, subtraction becomes divide. Done. I made it one log. They asked me to make it one log.
How did you change that? Oh, okay. The half made the whole thing through.
Yeah, because the half is on the whole thing here.
Right.
So that means a root on the whole thing. Exactly. Is that good? Questions on that? There'll be ones just like this on the test Thursday. So I made it into one log. Question? Yeah, no, good question. Same thing. Yeah, these two roots you could just say I'm going to make one big root. It's the same thing as log base 7 of one big root. Exactly the same. Either way is fine. Good. All right, shall we go? Let's try it. All right, number 11. All right, let me give you a second. I think you get more out of it if you do it first. So try number 11. Natural log of 3x equals negative x plus 3. Try number 11. All right, what are we supposed to do in number 11? Silence falls over the crowd. Nobody knows? What are we supposed to do in number 11? What do we do? If in doubt, read the words. What are we supposed to do in number 11? Just type it in. That's not a by hand problem. Is everybody getting that? Now, I want to help you with this. I don't know why people miss this question on the test. Right? Do you get what they're saying? So, use a graphing calculator. That means you ain't going to do it by hand. That means it's too hard to do by hand. Right? Would it help you if I tried and you watch me fail? You can all laugh at me. Right? I mean, how are you going to solve that? Well, give me an idea. What are we going to do? How are you going to get x alone? One of the x's is buried inside the toaster of a natural log. The other one's sitting out free. How are you going to get those together? You might think, well, you just said, Ms. Aaron, 2x to give them the same side. Okay, sure, all right. Move it over here. Get it on the same side. Then factor it out? Oh, really? You can't do that. I don't know if you think that's true, but that's completely, I hope you don't think that's true. That's not true. You can't have it like multiply back. No, if it multiplies, it goes to the front. It doesn't go back inside the toaster. No. Anyway, no. It can't be done by hand. Lots of things can't be done by hand. I don't know if you ever stop to realize that, you know, by the greatest mathematicians. Lots of things have been proven that they'll never be able to be done by hand. Do you know that? There's a whole area of math called existence proofs where they've shown many things. Not only do we not currently know how to solve it, it will never be solved by hand. There is no closed form answer ever. They've proven they can't ever be done. So we need technology. So this is, you got to use technology. Okay, so how do we do technology on this one? What do we do? So remember the left side is y1. So I want to also help with the graphing calculator. I know this gets a lot of people. So let me help. This should be free points to you. I always feel bad when I'm grading the test on these ones and I got to give a 0 on this. I'm like, oh shoot, what happened? Just y1's the left side, y1's the right side. Graph it on your calculator, and then after you have the graph, what do you hit? You hit set on the TI anyway. Hit second calc, and then the go down to the intersect, and just hit enter. This should be free points for you on that. Does that make sense? So when it says use the graphing calculator, it means it's too hard to do by hand. Just let y1 be the left side, y2 be the right side. Make sure you use the negative, not the subtraction. You know, it gets really, really upset about that. Negative x, right, with the parentheses on that negative x, or y2, negative x. If you ever do your calculus with syntax error, it's often that. Look to see if you use the wrong minus sign somewhere. It wants the negative, not the subtraction. Anyway, then graph them, and you should get some kind of graph that shows it. Now, if you can't see them in, what if you graph and you see nothing, or you just see one line, you can't see the intersection of the two? What should you do? If you can't see the intersection, if you cannot see the intersection on the screen, then hit second table, which is up in the top, and look at the y1, y2 values and change your window to include the y1, y2 values. Remember all that? So if you hit the graph button and you're just not seeing the intersection, go hit second table, it'll show you the y values, and then just adjust your window to include those. You know, go back to your window and adjust it to include those values, and then graph it again, and then do the intersection thing. Does that make sense? Somebody got an answer? What are we getting there? What's the x value? 1.5, then it goes on and on.
Well, it's,
So you
that's
only-
rounded. It's 1.5.
1.5, how about one more? 1.5.
And then the y is 1.5.
Yeah, I don't care
Oh,
about what.
oh, you want that? Oh, it's actually 1.49.
1.497.
Great, 1.497. Okay, sounds good.
And they want 2 decimals.
497, yeah, so 50, I guess you're right, so we'd actually round to 1.50.
So you
Yeah,
were just wanting the x.
yeah, we don't care about the y, because the original just had x, right? The y is just the height of the natural log, and the height of the minus, where it's the height where the two meet, right? But we just want the x, 1.50. So that makes you guys able to get that in your calculator. Grab me after if you're having trouble doing that. You should get that for sure. And let's see. All right, number 12. All right, let's try. We got to get through 12 and 13. Times are running. What do we do when we have a couple of logs? Overhead's getting tired.
Can't you use those, like, the rules?
Yeah, it's the right. Use the property sign. I called it the log countdown to help you remember. It's going to be 2 logs, 1 log, no log. Right, using the properties, yeah. So this first line has 2 logs. So next line I'm going to make it 1. So you know how to make it 1, right? The adding in the middle becomes times, huh? Like that. Right, good to there. What if that had been minus in the middle? Then it would be x minus 1 over x minus 7, wouldn't it? Right. So if there's minus in the middle, it would have been divide, because remember minus goes with divide. If there's adding in the middle, which there is, it becomes times, x minus 7 times, x minus 1 times x minus 7. So that's the 1 log. So 2 logs, 1 log. Now, how do I go to no logs? I'm counting them down, right? 2 logs. Now there's only 1 log. Next line there's going to be no log. The golden log rule, as I've named it anyway, right? Get rid of the log. Lose the log. What happens when you lose a log? Right? When you lose the log, base stays the base. Base stays the base. It's the golden log rule. Base is base. Other 2 switch. Yeah. So lose the log, base stays the base. Other 2 switch. What other 2? Meaning all the x stuff and the 3. Trade spots. So instead of 3 to all the x stuff, it's 3 to the 3. And all the x stuff goes over there. Is that good? Like that? Instead of 3 to all the x stuff, it's 3 to the 3. The x stuff goes over there. And then 3 to the 3 is 27. Then distribute this. We got x squared minus 7x minus 1x plus 7. You're all good to there. What in the world do I do now? So the logs are gone. I've got rid of all the logs. Now it's just normal solving, but that doesn't make it easy necessarily. What should I do at this point? Yeah, whenever you see x squared with an equal sign, remember the game plan is to get a 0 and then factor. So yeah, subtract that 27 to get a 0, and this will be x squared minus 8x minus 20. Factor, what is it, minus 12 plus 2? No. It's like making stuff up. What times what's 20? Yeah, 10 and 2, huh? Minus 10, oops, I'm scribbling here. Minus 10 plus 2, huh? Because that would multiply. Remember, they have to multiply to be negative 20. They have to add to be negative 8 in the middle, right? So negative 10 times 2 is negative 20, and they add to be negative 8, right, on that. And so what are the answers then? Well, the answer, remember, it's opposite, so the answers are plus 10 and minus 2. When you set each of those to 0, you know, it just jumps to the other side and changes signs. So plus 10 and minus 2. Now, are they both acceptable?
No.
Yeah, no negative inside of a log, so throw away that. The only answer is the plus 10 is the real answer to that problem. Let me show you the last one and we'll be done. Is that good? Questions on that? So 2 logs, 1 log, no log. Question?
Couldn't we just like put it in the
Quadratic form?
in the y equation like we did with the number 11?
Oh, with the calculator.
Yeah.
Yeah, that might work. It might give you the answer. Yeah, try left side, right side, yeah. All right, let's go to number show. All right, what do we do for this one? Let me give you a second. See what you remember. This will be the end of part 2. Find the effective rate. How do you find effective rate? Remember, for effective rate, there will definitely be one effective rate problem. Put in $1 for 1 year. And then take your answer and subtract original dollar. Remember that? So 6 1/4 is, I would just change it to a decimal. 6.25%, right? A quarter is 0.25. So which formula I use, a PERT or the other one? The other one, because it's compounded monthly, not continuously. So N is 12. So I'm going to use A is P 1 plus R over N to the NT. So the amount will be $1. Put in a principal of $1. That's your P. 1 year, that's your time. Your rate is 0.0625. The N is 12, compounding 12 times a year. And there's the T is 1. Hit the buttons on your calculator. Somebody got that? 1 point something or other. So I'm betting 1.063 something be my guess. Four like that. 1.06. So 1.0643. Like that. Can you give me one more? 1.0643. 2, okay. And so then remember, there's our answer. You subtract the original dollar because you just want the growth, right? You don't want the original dollar. You put in $1. So the 0.06 is the growth. Change that to a decimal. Move it 2 places. 6.432%. I think they want it rounded to hundreds. So 6.43. We'll just say 6.43%. That means 6.25 is really 6.43. 6.25 done monthly is really 6.43 done once a year. Remember, that's what the effective rate means. What's the real effect in 1 year? Your money will really grow by 6.43% when you do 6.25 12 times a year. All right, Thursday's a real deal. Didn't have time to go over part 1 as I knew. Come see me, be glad to help. Part 1 and 2 both on Thursday. And that 11.1 we covered is not due till next Tuesday. Have a good day, guys.